Programming-based CAD applications allow users to define models through a textual description using a programming language. These applications typically provide a code editor and a viewer that renders the model after compiling the code. Programming offers valuable features such as precision, ease to performing repetitive actions, abstraction, and version control. When creating a model, geometric properties can be defined with raw numbers. This can be inconvenient if the model is intended to have a structured format, as it forces users to update all dimensions if modifications are needed. Parametric designs allow the user to define properties based on parameters that relate different geometric properties, enabling rapid modifications and flexibility. Creating parametric models with programming-based applications requires users to define geometric properties using programming and arithmetic expressions. This can be challenging. For instance, in this spotlight holder example, deriving the expression in line 65 to place the highlighted part is not trivial. Interestingly, if the part is meant to be next to the spike, both positions must be related. Applications could provide the spike's information, facilitating the placement of the highlighted part. However, CAD applications do not provide such assistance. We explored how interactions can facilitate the definition of geometric properties in programming-based CAD. Our research began with a formative study to understand how geometric properties are created. We analyzed 30 OpenSCAD models from Thingiverse, selecting the most popular model under various search filters. We examined how primitive and spatial transformations are defined, categorizing them into 5 groups: raw numbers, single variable calls, linear combinations of variables, polynomial expressions, and more complex programming structures. We modified OpenSCAD to analyze the code, counting and classifying geometric properties definitions. Our findings reveal that scale transformation is infrequently used, and most rotations are defined with raw numbers at the standard values, suggesting that creating rotations is challenging. Additionally, most primitive and translate definitions fall into categories C1, C2, and C3. Given the linear nature of defining geometric properties and the ease of understanding these definitions in the view, our objective is to enable users to extract information from the view for reuse in the code using the programming-based CAD application OpenSCAD. First, we redefine the constructive solid geometry definitions of primitives to include selectable handles or points of interest from which users can retrieve information. We implemented 2 features: position and delta vector. Position allows users to extract the parametric location of a handle. After enabling these features in the menu, users can right-click on the view to select specific elements. The menu displays the CSG nodes, and users can select one. Once the handles appear, the user can right-click on a handle, and the application will place the parametric definition in the clipboard when the handle turns green. This definition can then be pasted into the code to parameterize other elements, positions, or dimensions. Delta vector allows users to determine the parametric vector between 2 handles. After selecting the delta vector option in the menu, users can select up to 2 parts. Then, by right-clicking on the origin handle and then the destination handle, the parametric vector is placed in the clipboard once both handles turn green. This vector can be used, for instance, in a translate statement to align both handles. In both cases, the definitions are parametric, ensuring that the geometric properties maintain a structure when the parameter value change. We conducted an experiment with 11 male participants, averaging 44 years of age and with approximately 9 years of experience in 3D design and programming. Participants were asked to replicate two models using the original version and our enhanced features. We recorded the screens and gathered user experience feedback. Our paper discusses the result in terms of user experience and performance. Participants generally found that the modified version of OpenSCAD and the implemented features made the design process easier. They noted that the features were easy to use, despite some usability issues such as the use of right-click instead of left-click, the order of selection for the delta vector, and the colors of the handles. Performance analysis showed that users made fewer errors and required fewer attempts to achieve a successful design, compared to the original version of OpenSCAD, although recovering from incorrect uses of the features was challenging. In the final discussions, participants expressed that these solutions could facilitate the entry of newcomers, streamline the design process, and help avoid mathematical errors. In brief, we began with a formative study to understand the nature of defining geometric properties in Programming-Based CAD. Based on our findings, we proposed design goals to facilitate parametric design in Programming-Based CAD and implemented them in OpenSCAD. We tested our solution demonstrating its potential. It is easy to use, can speed up the design process, facilitate the tasks for newcomers, and help users to avoid errors in the design process. Thank you.